Now in our last problem, I said, if only there was an easier way for us to solve this. Well, probably the hardest part last time was converting our density units. Converting density is terrible. However, there is an easier way to do it. And we do it through something called specific gravity. Now, to be honest, specific gravity has nothing to do with gravity. It has everything to do with you specifically. So, if you pick anything up in this world, whether you realize it or not, you're comparing it to something. If I pick up a pencil, if I pick up a piece of metal, I'm comparing that to something. If it feels light to me, why does it feel light? If it feels heavy to me, why does it feel heavy? Now, what you are likely comparing everything to is water. You don't realize that, but you are. Why water? Because you are constantly dealing with water. You're drinking water, you're bathing water, you're swimming in water. You are 70% water. And so we developed something called specific gravity, which simply says, sometimes things feel heavier than I expected or lighter than I expected. And why? Because I'm comparing it to water. So let's make a ratio for that. So specific gravity is simply the density of an object divided by the density of water. Now, since it's density on the top and the bottom, it has no units, as you can see right here. And what that tells me then is that if I have a specific gravity that is greater than 1, then it's more dense than water. If I have a specific gravity that's less than 1, it is less dense than water. So metals are usually somewhere around like 17 to 20 for metal. Other things can vary quite a bit. Liquids around the 1-ish area. Gases, very, very, very small fractions. Now, why do I care about this? Well, the reason you care is because the density of water is actually already known for a whole bunch of different units. Like, for example, it's 1,000 kilograms per meter cubed. It's 1 kilogram per liter. It's 1 gram per centimeter cubed. It's 62.4 pound mass per foot cubed. You can look it up. You can find all of these. And since all these things are the exact same thing, they're the density of water, I can use them as unit conversions for density. I can use them to very quickly go from one to the other. In fact, rather than give the density of an object, which isn't all that helpful, most of the time people give specific gravity for objects, because then I can choose whatever units I want and just use specific gravity to calculate that, rather than trying to do it the other way around where I have density, I calculate specific gravity and then I go back to density again. So it saves you time. The other term we're going to run into is specific weight. It's just another way of looking at how I treat objects, because density is technically mass over volume. That's density. But you don't actually feel masses, because you just don't. The only way you can tell if something is tell if something has mass is, one, you can say, okay, it feels heavy to me, which means I'm feeling a force and I'm now connecting it to mass. Or two, it's really hard to accelerate. I'm feeling the force I have to apply and I'm connecting that to mass. So eventually people are like, well, why are we looking at mass, which I always feel through forces? Why not look directly at force? So that's a Newton right there. And specific weight is simply saying, what is my particular amount of weight in a volume? It's also simply equal to density times gravity. So if I know how much weight I have in a particular volume, which is what I'm going to be feeling in the first place, I can use that to get density if I wanted to, and from that a whole bunch of other properties. Now, I don't usually do this, but we're going to go ahead and go right into the example because it's really connected to what we're doing right now. So, this example should look very, very familiar to you. Why? Because it's the exact same example we did earlier. So we're going to figure out what the specific volume is for a control volume of 4.78 yards cubed filled with this motor oil, which has a density of 860 kilograms per meter cubed. How are we going to do that? Well, not the way we did it last time, because that took a lot. We're going to do it using specific gravity, and what I talked to you about how density and specific volume are connected. So first off, I'm going to calculate specific gravity. It tells me the density of this motor oil is in kilogram per meter cubed. So I'm going to use the density of water in kilogram per meter cubed, which is 1,000. That gives me a specific gravity of 0.86. Now my final units are foot cubed and pound mass, so I'm now going to use specific gravity to calculate density. I can go back and forth. I just rearrange how I wrote the equation. So let's do that. So this is my equation, but if I multiply both sides by the density of water, what I get is about my density, whatever I care about, is simply specific gravity times the density of water. And do not just plug 1,000 back in here. I have to use the units that I actually want. I want units of pound mass in foot cubed, so I use the density of water in pound mass in foot cubed. And so that comes out to have 53.7 pound mass per foot cubed. This is already way simpler. And we take that last step of simplicity and we say, okay, let's calculate specific volume. So how do we do that? Well, remember that this is simply 1 over density. It's the inverse density. And so I take 1, I divide by my density, and I get my specific volume. That was a lot faster. That was a lot easier. And so this brings us to an important point. I know the shortcuts for a lot of these problems. When you're solving a problem like this, you might think, wow, that was so easy. Why was it so hard for me? Don't feel bad about that, because just like, I know the fastest way to get to my house. I know how to get there. I know all the shortcuts to get there. Yay, I'm at my house. Wonderful day. You might not. Hopefully you don't know where I live. But it doesn't matter if it took you a lot longer to get there if you get to the same point, okay? Over time, you will get better and better at doing these problems. You'll find the shortcuts. You don't need to know those to start. It's okay. You'll figure them out as we go through this course together. So thanks for listening. I'll see you all next time. Bye-bye.